Hello viewers, I am Ashim Roy. Welcome to my new educational channel, The Difference Between. Today I shall explain the basic difference between the series combination and parallel combination of resistances in current electricity. Let us first explain the circuit diagram for series. Suppose there are three resistances R1, R2 and R3 connected end to end, that is in series combination. Now there is an ammeter in the circuit which measures the amount of electric current passing through the circuit, and very important point is that the positive terminal of the ammeter must be connected to the positive terminal of the battery, and negative terminal of the ammeter in turn must be connected to the negative terminal of the battery. This is the source voltage V. There is a key which can open or close the circuit, and when it is on, then the current will flow through the circuit. Now we know that the electron is moving from negative terminal in this direction, and the conventional direction of electric current is considered to be in the opposite direction, that is opposite to the flow of electrons. Therefore, I amount of current delivered by the battery will pass through ammeter and will pass through the three resistances R1, R2, R3. Now I shall explain why the same amount of electric current I will pass through R1, R2 and R3. For that I want to take the help of these three pens. Suppose there are three pens similar to the water pipes of different cross section. Water entering through this pipe will enter through this pipe and comes out to this pipe. Now there is no leakage on the side. Therefore, the amount of water flowing through this pipe will come out through this pipe. Okay. In the same way, R1, R2, R3 are three different resistances. Since there is no junction or any other connection in between A, B, C, then the same amount of current will flow through R1 and R2 and R3, and that is the most important point in series combination. Now the potential difference across the resistance R1 will be equal to VA minus VB. Now why VA minus VB, not VB minus VA? Because the potential at A is more than the potential at B, and that's why the difference is VA minus VB. Therefore, by Ohm's law or Ohm's formula, VA minus VB is equal to current into resistance, that is I into R1 for this resistance. For the second resistance R2, in the similar way, the potential at B is more than the potential at C. Therefore, the difference is VB minus VC equal to, again by Ohm's formula, I into R2. In the same way, VC minus VD is equal to I into R3. Now, since the source voltage is given V, that is the battery voltage V, therefore this V must be equal to the sum of the potential differences across the three resistances. Therefore, we can write V equal to VA minus VB plus VB minus VC plus VC minus VD. Okay. In place of VA minus VB, I can write IR1 written. Similarly, for VB minus VC can be replaced by IR2, and then VC minus VD, IR3 will be equation number 1. Now, if we replace all the three resistances by a single one, that is capital R, which is called the equivalent resistance of this combination, with the same circuit, then the amount of current flowing through the circuit will be I. Again, by Ohm's formula, V, that is source voltage, is equal to current into equivalent resistance IR. So this is equation 2. Now you can see that equation 1 and equation 2, equating these two, we can get IR equal to IR1 plus IR2 plus IR3. Taking I common algebraically from the three terms and then cancelling I, we get R is equal to R1 plus R2 plus R3, which is the equivalent resistance of the series combination. Now I go to parallel combination of the resistances. Suppose there are again three resistances R1, R2 and R3 connected in such a way so that one end of the three resistances are connected to a single point A and the other end of the three resistances are connected to another single point D, and this combination is called parallel combination. Now again I use these three pens. Suppose this is the river, main river, and there are three tributaries of the river. Okay. Now water flowing through this main river will be distributed among these three tributaries, and after joining, these tributaries again will form the same river. Therefore, water flowing through these will be shared or distributed in these three tributaries. Similar in the case of parallel combination. Suppose current supplied by the battery I entering at A will be shared or distributed among three resistances R1, R2, R3. Let it be I1 through R1, then current I2 through resistance R2, then current I3, resistance I3. Again, by joining, after joining at point D, these three currents I1, I2, I3 join to form the net current I, and that's why the equation I, the net current supplied by the battery, is equal to I1 plus I2 plus I3. Okay? Since point A and point B is connected to the battery, therefore potential difference across each resistances must be equal to VA minus VD, which is equal to the source voltage V. Therefore, the voltage across three resistances will be same, that is V. Therefore, by using the Ohm's formula, current I1 must be equal to the common voltage V divided by R1 resistance. Similarly, current I2 will be equal to common voltage V divided by resistance R2, and I3 is equal to, in the same way, V by R3. Putting the values of I1, I2, I3 in this equation, we get I is equal to V by R1 plus V by R2 plus V by R3. Taking V common, so V into bracket 1 by R1, 1 by R2 plus 1 by R3 as it is written. Again, let us replace the three resistances by a single resistance, which is called the equivalent resistance in this parallel combination. So let it be designated by capital R. This is the equivalent resistance of the parallel combination, and the rest of the circuit will remain same: ammeter, battery, key. Okay. Now in this circuit, the net current I must be equal to the source voltage V by this capital R by Ohm's formula. Therefore, equating equation 1 and 2, we get V by R. V by R, that is this V by R equal to this one. V into bracket 1 by R1 plus 1 by R2 plus 1 by R3. Thus, cancelling V from both sides, we get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, the basic difference between this series and parallel combination is that in series combination, the resistances are connected end to end. Okay? And here, the resistances are connected in such a way so that one end of all the three will be connected at a single point and other end will be connected at other single point. Second point is that in series, the current flowing through each resistances will be same, whereas in parallel combination, the current flowing through each resistance will be distributed and therefore different. Third one will be the formula. In series, the resistances, equivalent resistance equal to sum of the resistances R1 plus R2 plus R3. In parallel combination, the equivalent resistance, that is reciprocal of the equivalent resistance 1 by R equal to sum of the reciprocals of individual resistances. Now, if there are n number of resistances, here only 3 resistances are given. If there are n number of resistances, what will be the formula? I write R equal to R1 plus R2 plus R3 plus dot 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 dot, that is continuation to Rn, which can be written as sigma Ri, I equal to 1 to n, that is the symbolic form. Similarly, in the case of parallel combination, if there are n number of resistances, then what will be the answer? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus again continuation plus 1 by Rn. Then this is again in symbolic form sigma 1 by Ri, I is equal to 1 to n. This is the generalized formula for series and parallel combination. Now you can see this is what is called the MIDI controller for programming music digitally. This instrument has a number of resistances connected in series and parallel in a very complicated way. Some resistances are pressure sensitive, like this one. Okay, so resistance, series and parallel combination are very important part in electrical gadgets and everywhere it is used. Now, what I can say you that if you want to see this calculation or the equations clearly, please zoom in. Okay. Thank you. Next time I shall explain the difference between the two in terms of numerical calculations. Okay. Thank you for watching the video. Okay. Bye.